Promotion of cleaner technologies. Public participation in environmental decision making. National Action Plan on Climate Change (NEPCC) 2008. The NEPC outlines India's strategy to address the impacts of climate change. It includes the national emissions. National solar mission. National mission on enhanced energy efficiency. National mission on sustainable habitat. National mission on sustainable agriculture, among others. Swachh Bharat Mission (SBM) launched in 2014. The Swachh Bharat Mission focuses on improving sanitation and waste management across India, promoting cleanliness, solid waste management, and eliminating open defecation. Biodiversity Action Plan. India has developed the National Biodiversity Action Plan (NBAP) to conserve its rich biodiversity, prevent species extinction, and promote sustainable use of biological resources. 4. International treaties for the protection of the environment. Environmental degradation is a global issue, and international cooperation is essential for addressing transboundary environmental problems. India is a signatory to several international treaties aimed at protecting the environment and promoting sustainable development. Key international environmental treaties. The Paris Agreement 2015. The Paris Agreement under the UN Framework Convention on Climate Change (UNFCCC) aims to limit global temperature rise to below 2 degrees Celsius above pre-industrial levels, with efforts to limit the rise to 1.5 degrees Celsius. India has committed to reducing its carbon intensity and increasing the share of renewable energy in its energy mix. The Kyoto Protocol 1997. This international treaty commits industrialized countries to reducing greenhouse gas emissions. Although India is not bound by emission reduction targets under the protocol, it has actively participated in global discussions on climate change. Convention on Biological Diversity (CBD) 1992. The CBD aims to conserve biodiversity, ensure sustainable use, and promote fair and equitable sharing of genetic resources. India has ratified this convention and has committed to conserving its biodiversity. The United Nations Convention to Combat Desertification (UNCCD). The UNCCD aims to combat desertification and land degradation, especially in dryland areas. India has actively participated in the convention's implementation to restore degraded lands and promote sustainable land management practices. The Montreal Protocol 1987. This protocol aims to protect the ozone layer by phasing out the production and consumption of ozone-depleting substances. India has ratified the protocol and is committed to phasing out harmful substances like chlorofluorocarbons, CFCs. The Ramsar Convention on Wetlands 1971. India is a signatory to the Ramsar Convention, which aims to conserve wetlands and biodiversity. The country has designated several Ramsar sites for the conservation of wetlands. Previous year questions. Discuss the major environmental issues India faces today and the government's approach to mitigate these challenges. Task Means 2021. Answer. India faces critical environmental issues like climate change, air and water pollution, deforestation, and biodiversity loss. The government has implemented various policies such as the National Action Plan on Climate Change, the National Environment Policy, and the Swachh Bharat Mission to address these challenges. Explain the importance of international environmental treaties in protecting the global environment. Discuss India's role in these treaties. Task Prelims 2020. Answer. International environmental treaties like the Paris Agreement, Kyoto Protocol, and Montreal Protocol are crucial in addressing global environmental challenges like climate change and biodiversity loss. India has played an active role in these treaties, committing to emission reductions and sustainable development. This lecture provides a comprehensive overview of environmental science, focusing on key issues, legal aspects, policies, and international treaties. Let me know if you'd like further elaboration on the next topic. You said. Environment protection for sustainable development. Biodiversity, its importance and concerns, climate change, international initiatives, policies, protocols, and India's commitment. ChatGPT said. Here's a detailed lecture on environment protection for sustainable development, focusing on biodiversity, climate change, and international initiatives, including policies and protocols with India's commitment, specifically tailored for the task officer, junior time scale training stream 1 exam. Environment protection for sustainable development 1. Environment protection for sustainable development. Sustainable development refers to development that meets the needs of the present generation without compromising the ability of future generations to meet their own needs. Environmental protection plays a pivotal role in achieving sustainable development by ensuring the long-term health of ecosystems, the sustainable use of natural resources, and the reduction of environmental degradation. Key elements of environmental protection for sustainable development. Conservation of natural resources. This includes the protection and sustainable use of water, forests, minerals, and land to ensure that these resources are available for future generations. Pollution control. Preventing and controlling air, water, and soil pollution is critical to maintain the quality of life on Earth and reducing the negative impacts on health and ecosystems. Waste management. The management of solid waste, particularly plastic waste, is vital to reducing pollution, conserving resources, and promoting recycling and reuse. Biodiversity conservation. Protecting the diversity of life forms, plants, animals, microorganisms is essential for ecosystem stability and the provision of ecosystem services like pollination, water purification. Biodiversity conservation. Protecting the diversity of life forms, plants, animals, microorganisms is essential for ecosystem stability and the provision of ecosystem services like pollination, water purification, and carbon sequestration. Climate change mitigation. The reduction of greenhouse gas emissions and the promotion of renewable energy sources, solar, wind, and hydropower are critical to slowing down the impact of global warming and climate change. 2. Biodiversity. Its importance and concerns. Biodiversity refers to the variety and variability of life forms on Earth, including species diversity, genetic diversity, and ecosystem diversity. Biodiversity is not only essential for the balance of ecosystems but also provides critical services that sustain human life. Importance of biodiversity. Ecological stability. Biodiversity contributes to stability of ecosystems by maintaining ecological processes such as nutrient cycling, soil formation, water regulation, and climate stabilization. Human well-being. Biodiversity supports food security, medicinal resources, and cultural heritage. Many plants and animals are used for food, medicines, and raw materials. It also plays a role in tourism, which is an important economic activity. Pollination and agriculture. Biodiversity is crucial for agricultural productivity through pollination of crops by bees, butterflies, and other insects. Carbon sequestration. Forests, wetlands, and oceans, as part of the global biodiversity, absorb carbon dioxide and help in mitigating climate change. Concerns. Habitat destruction, urbanization, deforestation, and agricultural expansion lead to habitat loss and fragmentation, threatening species with extinction. Overexploitation, overfishing, hunting, and unsustainable use of natural resources are driving species to extinction. Pollution. Pollution from industrial waste, plastics, and chemicals is harming wildlife and habitats. Climate change. Climate change is altering habitats and causing shifts in species distribution, threatening biodiversity. Invasive species. Non-native species introduced by human activities often outcompete indigenous species, leading to a decline in local biodiversity. 3. Climate change. Global issue and its impact. Climate change refers to long-term changes in temperature, precipitation, and weather patterns that are due to human activities, particularly the burning of fossil fuels, coal, oil, and gas, which releases greenhouse gases GHGs like carbon dioxide, CO2, methane, CH4, and nitrous oxide, N2O into the atmosphere. Impact of climate change. Global warming. The increase in average global temperatures leading to melting of glaciers and ice caps, rising sea levels, and extreme weather events like heat waves, droughts, and floods. Loss of biodiversity. Climate change is causing habitat shifts, changing migration patterns, and altering ecosystems, threatening the survival of many species. Agriculture. Changing rainfall patterns, increased frequency of droughts, and shifting temperature zones can reduce crop yields and food security. Human health. Rising temperatures contribute to the spread of vector-borne diseases such as malaria and dengue, heat-related illnesses, and respiratory problems caused by air pollution. Water scarcity. The melting of glaciers and changing precipitation patterns reduce the availability of fresh water in many regions. 4. International limits, policies, protocols, and India's commitment. Since climate change is a global challenge, it requires international cooperation to mitigate its effects. Several global policies, protocols, and agreements have been created to address the issue. Key international initiatives on climate change. The United Nations Framework Convention on Climate Change (UNFCCC). The UNFCCC, adopted in 1992, is the primary international treaty aimed at combating climate change. It established a framework for international negotiations on reducing greenhouse gas emissions. The Kyoto Protocol 1997. The Kyoto Protocol established legally binding emission reduction targets for developed countries. However, it did not require developing countries like India to reduce their emissions. India was not legally bound by emission reduction targets but participated in mechanisms like carbon trading and the clean development mechanism (CDM). The Paris Agreement 2015. The Paris Agreement is a landmark international treaty under the UNFCCC that commits all nations, both developed and developing, to reduce emissions and limit global warming below 2 degrees Celsius compared to pre-industrial levels, with efforts to limit it to 1.5 degrees Celsius. It is the first agreement to involve nationally determined contributions (NDCs), which means each country commits its own emission reduction targets and plans. India's role in the Paris Agreement. India committed to reducing its carbon intensity emissions per unit of GDP by 30-35% by 2030 or 2005 levels. India also pledged to increase the share of renewable energy in its total energy capacity to 40% by 2030. India has set ambitious targets under the National Action Plan on Climate Change (NEPCC) to expand solar energy, improve energy efficiency, and promote sustainable agriculture. The Montreal Protocol 1987 is international treaty aims to protect the ozone layer by phasing out the use of ozone-depleting chemicals such as chlorofluorocarbons (CFCs). The protocol has led to significant reductions in the use of harmful chemicals and the gradual recovery of the ozone layer. The Convention on Biological Diversity (CBD) 1992. The CBD is an international treaty aimed at conserving biodiversity, ensuring its sustainable use, and sharing its benefits equitably. India as a signatory has developed its own National Biodiversity Action Plan (NBAP) to protect its biodiversity. 5. India's commitment and actions for climate change and biodiversity conservation. India has taken significant steps to combat climate change and protect biodiversity. National Action Plan on Climate Change (NEPCC) launched in 2008. The NEPCC outlines India's strategy for climate change mitigation and adaptation. It includes measures on solar energy, energy efficiency, sustainable agriculture, and water conservation. Renewable energy expansion. India is aiming to expand its renewable energy capacity to 500 gigawatts by 2030, focusing on solar and wind power. It has set a target of achieving 175 gigawatts of renewable energy by 2022. National Biodiversity Action Plan (NBAP). India's commitment to biodiversity is demonstrated by its participation in the Convention on Biological Diversity and its efforts to conserve endangered species and protect key ecosystems like forests, wetlands, and marine areas. Afforestation and reforestation. India is actively engaged in efforts to increase forest cover and reduce deforestation, particularly through the green emission and various deforestation programs aimed at restoring degraded lands. Previous year questions. Discuss India's commitments under the Paris Agreement and its approach to mitigating climate change. Past means 2022. Answer. India has committed to reducing its carbon intensity by 33-35% by 2030 and increasing the share of renewable energy to 40% by 2030. The country has also focused on expanding solar energy and energy efficiency, as outlined in the National Action Plan on Climate Change (NEPCC). What are the major international treaties related to biodiversity conservation? Discuss India's role in these. Past prelims 2021. Answer. Major treaties include the Convention on Biological Diversity (CBD) and the Ramsar Convention on Wetlands. India has ratified the CBD and developed the National Biodiversity Action Plan (NBAP) to conserve its rich biodiversity. This lecture provides a comprehensive overview of environmental protection, biodiversity, climate change, and international initiatives aimed at addressing these critical issues with a focus on India's commitment. Let me know if you would like further elaboration on any topic. You said. Western gas features, characteristics, and issues. ChatGPT said. Here's a detailed lecture on Western gas, covering its features, characteristics, and issues, specifically tailored for the gas officer junior timescale training stream 1 exam. Western gas features, characteristics, and issues 1. Introduction to the Western gas. The Western gas, also known as the Sahara Beetles, are a mountain range that runs parallel to the western coast of India, stretching from the state of Gujarat in the north to Tamil Nadu in the south. They are one of the 8 hottest hotspots of biological diversity in the world, and they play a critical role in the climate and ecological balance of the Indian subcontinent. The Western gas are a UNESCO World Heritage Site due to their immense biodiversity and unique ecosystems. 2. Features of the Western gas. Geography and extent. The Western gas covers an area of approximately 1,600 kilometers and passes through 6 states: Gujarat, Maharashtra, Goa, Karnataka, Kerala, and Tamil Nadu. The mountain range is predominantly rain-fed and has several low ranges, valleys, and river systems. Elevation and topography. The elevation of the Western gas ranges from around 900 meters to 2,600 meters above sea level. The highest peak is Anhui, 2,695 meters, located in Kerala. The gas consists of steep ridges, plateaus, gorges, and rolling hills, contributing to the diverse landscape. Rivers. Many important rivers of the Indian subcontinent originate in the Western gas, such as the Godavari, Krishna, Kaveri, and Tungabhadra, which are vital sources of water for agriculture, drinking, and hydroelectric power. Biodiversity. The Western gas are home to a wide variety of flora and fauna, many of which are endemic to the region. These include species such as the nuri tar, lion-tailed macaque, western gas giant squirrel, and various species of frogs, birds, and plants. The region also houses rich forests, including tropical rainforests, deciduous forests, and shelf forests. 3. Characteristics of the Western gas. Climatic influence. The Western gas influences the monsoon climate of the Indian subcontinent by acting as a barrier to southwest monsoon winds. This results in heavy rainfall on the windward side, western slopes, and dry conditions on the leeward side, eastern slopes. This phenomenon is responsible for the formation of rainforests and humid subtropical forests on the western side. Rich flora and fauna. The Western ghats have a rich diversity of plant species, with more than 7,000 species of flowering plants, including several endemic species. The fauna of the Western ghats is equally diverse, with more than 500 species of birds and 160 species of mammals. The region is also home to several species of reptiles, amphibians, and insects that are endemic to the area. Ecological importance. The Western ghats are ecologically important for soil conservation, water retention, and soil erosion. They also serve as carbon sinks, playing a role in mitigating climate change by absorbing carbon dioxide from the atmosphere. The forests of the Western ghats provide numerous ecosystem services, such as air purification, water regulation, and biodiversity maintenance. Cultural significance. The Western ghats have deep cultural and historical significance, with several ancient temples, pilgrimage sites, and traditional communities residing in the region. The Nilgiri Hills of the Western ghats are famous for tea and coffee plantations, which are key aspects of the local economy. 4. Issues facing the Western ghats. While the Western ghats are of immense ecological, cultural, and economic value, they face numerous challenges that threaten their sustainability. Deforestation and habitat loss. Deforestation due to urbanization, agriculture, and commercial plantations has resulted in the loss of critical habitats for many species. The expansion of tea, coffee, and rubber plantations, along with logging, has led to the degradation of the natural forest cover. Fragmentation of ecosystems. Fragmentation caused by human settlements, roads, and infrastructure projects has disrupted the connectivity of habitats, leading to a loss of biodiversity. Wildlife corridors have been severed, making it difficult for species to migrate, breed, or access resources, resulting in reduced genetic diversity. Climate change. Climate change poses a significant threat to the Western ghats, altering rainfall patterns, increasing temperatures, and changing the dynamics of the ecosystems. The region is highly vulnerable to heat waves, droughts, and forest fires, which further stresses biodiversity. Pollution. Pollution from industrial activities, mining, construction, and plastic waste has degraded the water quality of rivers originating from the Western ghats. Air pollution from nearby urban centers also affects the air quality in the region, impacting both human health and wildlife. Overexploitation of resources. Overgrazing by livestock, illegal logging, and the unregulated extraction of minerals and timber have caused further depletion of the region's natural resources. These activities lead to soil erosion, desertification, and the destruction of fragile ecosystems. Illegal wildlife trade. The illegal wildlife trade of plants and animals from the Western ghats is another major issue. Species such as the tiger, elephant, and endangered plants are targeted by poachers and traffickers, further threatening the region's biodiversity. Invasive species. Invasive species, both plant and animal, introduced by human activities, are disrupting local ecosystems by outcompeting native species for resources. This has led to the decline of indigenous species and has caused imbalances in the food chain. Hydroelectric projects. The construction of hydroelectric dams on rivers originating from the Western ghats has disrupted natural water flow, affecting both aquatic and terrestrial ecosystems. These projects also displace local communities, further exacerbating socioeconomic challenges in the region. 5. Conservation efforts and challenges. Several conservation measures have been undertaken to protect the Western ghats and their biodiversity. UNESCO World Heritage Site. The Western ghats were designated as UNESCO World Heritage Site in 2012, which has helped raise awareness and attract international funding for conservation efforts. Western Gas Ecology Expert Panel WGEP. In 2010, the government of India constituted the WGEP to assess the environmental status of the Western ghats and recommend measures for conservation. The panel emphasized the need for better management practices, eco-sensitive zones, and the protection of ecologically sensitive areas. Protected areas of wildlife sanctuaries. Numerous national parks and wildlife sanctuaries, such as Silent Valley National Park, Periyar Wildlife Sanctuary, and Rajmahal Air National Park, have been established to conserve the biodiversity of the Western ghats. Elevate corridors have been set up to ensure the safe movement of wildlife across the landscape. Community involvement. Various community-based conservation programs are being implemented, with local communities engaged in sustainable agricultural practices, ecotourism, and biodiversity monitoring. Challenges. Despite these efforts, the challenges persist due to inadequate enforcement of laws, political pressures from developmental activities, and conflict between conservation and livelihoods. Balancing the needs of local communities and the protection of biodiversity remains a significant challenge. Previous year questions. Explain the geographical features and ecological significance of the Western ghats. Discuss the conservation efforts to protect this region. Past means 2021. Answer. The Western ghats are a mountain range extending along the western coast of India, influencing the monsoon climate and providing critical habitats for a wide range of species. Conservation efforts include the designation of UNESCO World Heritage Site, the establishment of wildlife sanctuaries, and community-based conservation programs. However, challenges such as deforestation and habitat fragmentation persist. What are the major environmental challenges facing the Western ghats, and what measures can be taken to address them? Past prelims 2020. Answer. Major challenges include deforestation, habitat loss, climate change, pollution, and the overexploitation of resources. Addressing these requires stricter enforcement of environmental laws, sustainable agricultural practices, and better management of protected areas. This lecture provides a comprehensive overview of Western gas, their features, characteristics, environmental significance, and the key issues they face. Let me know if you need further details on any of these topics. You said. Forest and wildlife, legal framework for forest and wildlife conservation in India. ChatGPT said. Here's a detailed lecture on forest and wildlife conservation in India, focusing on the legal framework that governs these areas, tailored for the CAS officer junior timescale training streamline exam. Forest and wildlife, legal framework for forest and wildlife conservation in India 1. Introduction to forest and wildlife conservation in India. India is home to rich biodiversity, including a vast array of forests and wildlife species. The protection and conservation of these natural resources are crucial for maintaining ecological balance, protecting habitats, and supporting the livelihoods of millions of people. The legal framework for forest and wildlife conservation in India aims to safeguard these resources through comprehensive laws, policies, and institutions. This framework also addresses issues such as deforestation, habitat destruction, and wildlife poaching. 2. Legal framework for forest conservation. India's legal framework for forest conservation is mainly focused on regulating forest use, ensuring sustainable management, and protecting forested areas. The following laws and policies play a significant role in forest conservation. Indian Forest Act, 1927. The Indian Forest Act of 1927 is a cornerstone of India's forest laws. It provides for the declaration of forest areas, defines reserved forests, and sets out procedures for the regulation of forests and their produce. The act also governs the management of forests, including the control of illegal logging, grazing, and encroachment. Reserved forests. These forests are legally protected and cannot be disturbed without government consent. They are primarily meant for conservation and sustainable management of forest resources. Protected forests. These forests are not as strictly protected as reserved forests, but they are still subject to some restrictions on activities like logging or grazing. Village forests. Areas set aside for the benefit of local communities, where they can use forest resources in a controlled manner. Forest Conservation Act, 1980. The Forest Conservation Act was enacted to prevent the diversion of forest land for non-forest purposes, such as industrial development and urbanization. It requires any proposal for the diversion of forest land be approved by the central government. The law has helped reduce deforestation and ensures that forest land is used only for critical development projects, subject to environmental safeguards. National Forest Policy, 1988. This policy aims to increase forest cover to 33% of the total land area of the country. The policy promotes deforestation, conservation, and sustainable management of forests, with a particular focus on community participation in forest management. It also stresses the importance of biodiversity conservation and water conservation in forest areas. Joint Forest Management, JFM. The concept of joint forest management was introduced in the early 1990s as a participatory approach to forest management. It involves collaboration between local communities and the forest department to manage and protect forest resources. Communities are given responsibilities and benefits from the sustainable use of forests. The Scheduled Tribes and Other Traditional Forest Dwellers, Recognition of Forest Rights Act, 2006. This act was passed to recognize the rights of forest-dwelling communities, particularly the Scheduled Tribes and other traditional forest dwellers. It ensures the right to use forest resources for their livelihood, as well as the right to conserve and protect forests. 3. Legal framework for wildlife conservation. India's wildlife laws and policies focus on protecting endangered species, preserving natural habitats, and controlling poaching and illegal trade. The following key laws and regulations in the wildlife conservation domain. Wildlife Protection Act, 1972. The Wildlife Protection Act is the primary law governing wildlife conservation in India. It provides for the protection of wildlife and habitats through the establishment of protected areas such as national parks, wildlife sanctuaries, and conservation reserves. The act also prohibits the hunting of specified wild animals, the trade of wildlife products, and the destruction of wildlife habitats. Key provisions include schedules. The act divides species into 6 schedules, with schedule 1 offering the highest degree of protection to endangered species like the royal Bengal tiger and Asian elephant. Protected areas. The act facilitates the creation of protected areas, which include national parks, wildlife sanctuaries, and conservation reserves. These areas are managed to ensure preservation of biodiversity and prevent human activities that could harm wildlife. Project Tiger, 1973. Project Tiger was launched in 1973 to ensure the conservation of tigers in India, which were under serious threat of extinction due to poaching and habitat loss. The project aims to provide protection to tiger habitats, enforce anti-poaching laws, and involve local communities in conservation efforts. India's tiger population has significantly increased since the launch of this initiative. Project Elephant, 1992. Similar to Project Tiger, Project Elephant was introduced in 1992 to conserve protect elephant populations and their habitats. The project includes measures such as anti-poaching activities, habitat restoration, and the creation of elephant corridors to reduce human-elephant conflict. National Biodiversity Act, 2002. The National Biodiversity Act aims to conserve biodiversity and promote sustainable use of biological resources. It provides for the establishment of the National Biodiversity Authority to monitor and regulate the use of biological resources and traditional knowledge, especially in the context of biopiracy and the commercial use of indigenous species. 4. Conservation challenges and solutions. Despite the robust legal framework, India faces several challenges in forest and wildlife conservation. Deforestation. The continuous expansion of agriculture, urbanization, and infrastructure development leads to forest destruction. Inadequate enforcement of laws and regulations also exacerbates deforestation. Solution. Strict enforcement of the Forest Conservation Act and increased deforestation programs can help reduce the rate of deforestation. Additionally, promoting sustainable farming and agroforestry practices can help in reducing the pressure on forests. Poaching and illegal wildlife trade. The illegal hunting of wildlife and trade of animal products remains a serious threat to many species, particularly tigers, elephants, and rhinoceros. Solution. Strengthening the enforcement of the Wildlife Protection Act, increasing the use of technology like drones and camera traps to monitor wildlife, and fostering international cooperation to combat illegal wildlife trade are essential steps. Human-wildlife conflict. As human settlements expand into forest areas, conflicts between humans and wildlife, especially elephants and tigers, have increased, leading to loss of life and property. Solution. The creation of wildlife corridors, improved early warning systems, and community-based conservation programs can help mitigate conflicts and ensure the safety of both humans and animals. Loss of biodiversity. The destruction of habitats due to deforestation, pollution, and climate change has led to the endangerment of several species and ecosystems. Solution. Conservation of critical habitats, restoration of degraded ecosystems, and the expansion of protected areas are critical for preventing further loss of biodiversity. 5. Previous year questions. Discuss the legal and institutional framework for forest conservation in India. How effective has the Forest Conservation Act, 1980, been in achieving its objectives? CAS means 2022. Answer. The Forest Conservation Act, 1980, provides for the regulation of the diversion of forest land for non-forest purposes. It has been effective in preventing indiscriminate deforestation, but challenges such as inadequate enforcement and legal encroachments persist. The establishment of protected areas and joint forest management has also played a significant role in forest conservation. Evaluate the effectiveness of the Wildlife Protection Act, 1972, in conserving endangered species. Discuss the role of Project Tiger and Project Elephant in this context. CAS prelims 2021. Answer. The Wildlife Protection Act, 1972, has been instrumental in the protection of endangered species by establishing protected areas and prohibiting poaching. Projects like Project Tiger and Project Elephant have significantly contributed to the recovery of tiger and elephant populations through habitat protection and anti-poaching measures. This lecture provides a comprehensive overview of legal framework for forest and wildlife conservation in India. Let me know if you need further details or clarification. You said. Environmental hazards, pollution, carbon emission, global warming, national action plans on climate change and disaster management. ChatGPT said. Here's a detailed lecture on environmental hazards, pollution, carbon emission, global warming, and national action plans on climate change and disaster management, specifically tailored for the CAS officer junior timescale training streamline exam. Environmental hazards, pollution, carbon emission, global warming, national action plans on climate change and disaster management. 1. Environmental hazards. Environmental hazards refer to any event or situation that poses a threat to the environment, causing harm to natural resources, ecosystems, or human health. These hazards can result from both natural processes such as volcanic eruptions, earthquakes, and human activities such as industrialization, deforestation, and pollution. Common environmental hazards include natural hazards, floods, droughts, hurricanes, earthquakes, landslides, etc. Human-induced hazards, deforestation, pollution, overexploitation of resources, climate change, and loss of biodiversity. These hazards can lead to irreversible damage to the environment and impact public health, agriculture, infrastructure, and the economy. 2. Pollution. Pollution refers to the contamination of the natural environment due to human activity, leading to harmful effects on ecosystems, living organisms, and climate patterns. The major types of pollution are air pollution, the release of toxic gases like carbon monoxide, sulfur dioxide, and nitrogen oxides into the atmosphere from sources like vehicles, industrial emissions, and the burning of fossil fuels. Air pollution leads to respiratory diseases, cardiovascular issues, and environmental degradation. Water pollution, contamination of water bodies, rivers, lakes, oceans due to the discharge of industrial effluents, agricultural runoff containing pesticides and fertilizers, and untreated sewage. Water pollution affects wildlife, public health, and disrupts water availability, drinking, and irrigation. Soil pollution, the degradation of soil quality due to the accumulation of toxic chemicals, including heavy metals, pesticides, and waste products. Soil pollution affects agriculture, leads to loss of soil fertility, and harms plant and animal life. Noise pollution. The presence of excessive noise, primarily from urbanization, industrial activities, and transportation. Chronic exposure to noise pollution leads to hearing impairment, stress, and cardiovascular diseases. Plastic pollution. The widespread accumulation of plastic waste in landfills, water bodies, and oceans. It has serious consequences on ecosystems, marine life, and human health due to the persistence of plastic in the environment. 3. Carbon emission and global warming. Carbon emission. Carbon emissions primarily refer to the release of carbon dioxide, CO2, and methane, CH4 into the atmosphere, meaning from the burning of fossil fuels, coal, oil, and natural gas for energy, transportation, and industrial processes. Deforestation and agricultural practices also contribute significantly to carbon emissions. Global warming. The increase in the Earth's average temperature due to the accumulation of global warming. The increase in the Earth's average temperature due to the accumulation of greenhouse gases, GHGs, in the atmosphere, primarily CO2, methane, and nitrous oxide. Global warming leads to a rise in sea levels, more frequent heat waves, and the melting of glaciers, disrupting ecosystems and human societies. The greenhouse effect is a natural process that keeps the Earth's climate warm enough to support life. However, human activities have intensified this effect, leading to rapid climate change. Global warming is associated with numerous impacts, such as extreme weather events, changes in rainfall patterns, droughts, and loss of biodiversity. 4. National Action Plans on Climate Change, NAPCC. The National Action Plan on Climate Change, NAPCC, was launched by the government of India in 2008 to address climate change by promoting sustainable development and reducing the country's carbon footprint. The NAPCC consists of 8 national missions, each targeting a specific aspect of climate change mitigation and adaptation. National Solar Mission, NSM, aims to promote the use of solar energy and increase the share of solar power in the energy mix. The goal is to achieve 20,000 megawatts of solar power by 2022. National Mission for Enhanced Energy Efficiency, NMED, focuses on improving energy efficiency through technological upgrades, implementation of energy efficient measures, and the creation of an energy efficient market. National Mission on Sustainable Habitat, NMSH, aims to promote energy efficient buildings, sustainable urban transport systems, and waste management practices to reduce urban emissions. National Water Mission, NWM, focuses on conservation of water resources, improving water use efficiency across sectors, and ensuring equitable distribution of water. National Mission for Sustainable Agriculture, NMSA, seeks to promote climate resilient agricultural practices, improve soil health, and optimize water use in farming to ensure food security in the face of climate change. National Mission on Strategic Knowledge for Climate Change, NMSKCC, aims to build scientific knowledge to create a robust database to help policymakers make informed decisions regarding climate change. National Mission on Inland Ecosystems, NMEG, focuses on preserving inland ecosystems by addressing the impacts of climate change on glaciers, rivers, and biodiversity in the region. National Mission for Green India, GIM, promotes the afforestation and afforestation of degraded forest lands to enhance carbon sequestration, protect biodiversity, and support rural livelihoods. Global warming. The increase in the Earth's average temperature due to the accumulation of greenhouse gases, GHGs, in the atmosphere, primarily CO2, methane, and nitrous oxide. Global warming leads to a rise in sea levels, more frequent heat waves, and the melting of glaciers, disrupting ecosystems and human societies. The greenhouse effect is a natural process that keeps the Earth's climate warm enough to support life. However, human activities have intensified this effect, leading to rapid climate change. Global warming is associated with numerous impacts, such as extreme weather events, changes in rainfall patterns, droughts, and loss of biodiversity. 4. National Action Plans on Climate Change, NAPCC. The National Action Plan on Climate Change, NAPCC, was launched by the government of India in 2008 to address climate change by promoting sustainable development and reducing the country's carbon footprint. The NAPCC consists of 8 national missions, each targeting a specific aspect of climate change mitigation and adaptation. National Solar Mission, NSM, aims to promote the use of solar energy and increase the share of solar power in the energy mix. The goal is to achieve 20,000 megawatts of solar power by 2022. National Mission for Enhanced Energy Efficiency, NMED, focuses on improving energy efficiency through technological upgrades, implementation of energy efficient measures, and the creation of an energy efficient market. National Mission on Sustainable Habitat, NMSH, aims to promote energy efficient buildings, sustainable urban transport systems, and waste management practices to reduce urban emissions. National Water Mission, NWM, focuses on conservation of water resources, improving water use efficiency across sectors, and ensuring equitable distribution of water. National Mission for Sustainable Agriculture, NMSA, seeks to promote climate resilient agricultural practices, improve soil health, and optimize water use in farming to ensure food security in the face of climate change. National Mission on Strategic Knowledge for Climate Change, NMSKCC, aims to build scientific knowledge to create a robust database to help policymakers make informed decisions regarding climate change. National Mission on Inland Ecosystems, NMEG, focuses on preserving inland ecosystems by addressing the impacts of climate change on glaciers, rivers, and biodiversity in the region. National Mission for Green India, GIM, promotes the afforestation and afforestation of degraded forest lands to enhance carbon sequestration, protect biodiversity, and support rural livelihoods. 5. Disaster management. Disasters, whether natural like earthquakes, floods, cyclones, or man-made like industrial accidents, chemical spills can have devastating impacts on life, property, and the environment. Effective disaster management is crucial for reducing the impact of disasters and ensuring quick recovery. Disaster Management Act, 2005. This act established the National Disaster Management Authority, NDMA, responsible for formulating policies, plans, and guidelines to manage disasters. The NDMA is headed by the Prime Minister, with specific missions for risk reduction and preparedness. Disaster management cycle. This includes the phases of mitigation, preparedness, response, and recovery. Mitigation involves actions taken to reduce the severity of disasters, such as building regulations and land use planning. Preparedness involves disaster preparedness drills and development of early warning systems. Response includes the immediate actions taken to assist affected populations, and recovery focuses on rebuilding and rehabilitation. National Policy on Disaster Management, 2009. This policy emphasizes the importance of integrating disaster risk reduction and development planning aims to strengthen the capacities of national, state, and local authorities to manage disasters effectively. State disaster management plans. States in India also develop disaster management plans tailored to specific risks, such as flood management in Bihar, cyclone preparedness in Odisha, and earthquake response in the Himalayan states. 6. Challenges and solutions. Challenges in climate change mitigation. Despite the NEPCC, challenges such as lack of funding, limited technological advancements, and policy incoherence hinder the implementation of climate action plans. India's dependence on coal for energy is a significant challenge in reducing carbon emissions. Solution. Strengthening policy frameworks, promoting renewable energy sources, and incentivizing green technologies can help address these challenges. International collaboration and funding for climate adaptation are also necessary. Challenges in disaster management. Lack of infrastructure, inadequate awareness, and insufficient preparedness are local level challenges in disaster management. Additionally, urbanization and poor planning exacerbate vulnerabilities to disasters. Solution. Implementing community-based disaster risk reduction programs, improving early warning systems, and creating disaster-resilient infrastructure are key measures to enhance disaster preparedness and response. 7. Previous year questions. Discuss the major national action plans formulated by India to combat climate change. How effective have they been in achieving the set targets? CAS means 2022. Answer. The National Action Plan on Climate Change, NEPCC, consists of 8 missions, targeting solar energy, energy efficiency, sustainable habitats, and other key sectors. While progress in progress, challenges such as funding constraints and slow pace of implementation in some areas have hindered full realization of the targets. Explain the importance of disaster management in India. Discuss the key provisions of the National Disaster Management Act, 2005, CAS prelims 2021. Answer. Disaster management is crucial in minimizing the human and economic losses caused by natural and man-made disasters. The National Disaster Management Act, 2005, provides for the establishment of the NDMA and sets guidelines for disaster risk reduction, preparedness, response, and recovery. This lecture offers a comprehensive overview of environmental hazards, pollution, carbon emission, global warming, and India's national action plans on climate change and disaster management. Let me know if you need further clarification on any of the topics. You said. Developments in biotechnology, green technology, and nanotechnology. ChatGPT said. Here's a detailed lecture on developments in biotechnology, green technology, and nanotechnology, specifically tailored for CAS officer junior time CL training stream 1 exam. Developments in biotechnology, green technology, and nanotechnology 1. Biotechnology, overview of developments. Biotechnology refers to the use of biological organisms or systems to develop products and technologies that address human needs. It merges biology with technology and plays a critical role in sectors like agriculture, healthcare, energy, and environmental conservation. Medical biotechnology. This involves the development of drugs, vaccines, and therapies that use biological substances. The use of genetic engineering has led to the creation of recombinant DNA technology, enabling the production of insulin, growth hormones, and monoclonal antibodies. Medical biotechnology also plays a role in gene therapy, where defective genes are replaced with repaired genes that repair disease or disorders. Agricultural biotechnology. Genetic modification techniques are used to create genetically modified GM crops that enhance nutritional value, resistance to pests, and tolerance to environmental stresses like drought and salinity. Examples include BT cotton, which is engineered to resist pests, and golden rice, enriched with vitamin E to combat malnutrition. Industrial biotechnology. Biotechnology is used in industrial processes such as the production of biofuels, biodegradable plastics, and chemicals. The use of biocatalysts in industrial processes has led to more environmentally friendly manufacturing methods, reducing the use of toxic chemicals and minimizing waste. Environmental biotechnology. This involves the use of organisms, such as bacteria and fungi, to degrade pollutants in air, water, and soil. Bioremediation is a key application, where biological processes are employed to clean up oil spills, wastewater, and heavy metals from contaminated environments. CRISPR-Cas9. The CRISPR-Cas9 technology has revolutionized genetic research and biotechnology by allowing for precise editing of DNA organisms, including humans. This has vast implications for genetic disorders, agriculture, and pharmaceuticals. 2. Green technology. Overview developments. Green technology refers to technologies that are environmentally friendly, designed to reduce the negative impact of human activity on the environment. It involves the development of products and processes that promote sustainability, reduce pollution, and improve the overall health of the planet. Renewable energy. Green technologies have been instrumental in advancing renewable energy sources such as solar, wind, biomass, and hydropower. The development of solar photovoltaic PV cells has led to more efficient and cost-effective solar energy systems. Wind turbines have become more efficient, leading to large-scale wind farms that generate significant amounts of electricity. The shift to these renewable sources of energy reduces reliance on fossil fuels, mitigating the effects of climate change. Energy storage and batteries. A critical aspect of renewable energy is energy storage. The development of advanced lithium-ion batteries and emerging fuel solid-state batteries helps store energy produced from intermittent sources like wind and solar, making renewable energy more reliable and widespread. Energy-efficient technologies. Green technology includes innovations designed to reduce energy consumption. This includes the development of energy-efficient appliances, smart grids, and LED lighting systems. The widespread adoption of energy-efficient buildings with insulation, passive solar heating, and coolers reduces the energy needed for heating and cooling. Carbon capture and storage. CCS technology involves capturing carbon dioxide emissions from industrial processes and power plants, compressing it, and storing it underground to prevent it entering the atmosphere and contributing to climate change. This technology has the potential to reduce carbon emissions from fossil fuel-dependent industries. Sustainable agriculture. Green technology also focuses on sustainable agricultural practices such as precision farming and use of biopesticides and biofertilizers. These innovations reduce the use of harmful chemicals and help conserve soil and water resources, promoting long-term agricultural sustainability. Water purification and desalination. Green technology plays a significant role in improving water management through advanced filtration systems, desalination plants, and water recycling technologies. These methods help address global water scarcity and ensure the availability of clean water. 3. Nanotechnology. Overview of developments. Nanotechnology involves manipulation of matter on a time or molecular scale, typically at a range of 1 to 100 nanometers. It is a rapidly advancing field with applications across multiple sectors, including medicine, electronics, materials science, and energy. Nanomaterials. Nanotechnology enables the creation of materials with unique properties that are not seen in bulk materials. Carbon nanotubes, graphene, and quantum dots are examples of nanomaterials that exhibit extraordinary strength, conductivity, and optical properties. These materials are used in various applications, including electronics, drug delivery systems, and energy storage. Nanomedicine. Nanotechnology has significant applications in medicine, particularly in drug delivery, diagnostics, and imaging. Nanoparticles are engineered to deliver drugs directly to targeted cells, improving the efficiency of treatments while reducing effects. Nanosensors are used for early disease detection, such as in cancer diagnosis, where they can identify biomarkers at very low concentrations. Nanoelectronics. Nanotechnology has led to the development of smaller, faster, and more efficient electronic devices. The miniaturization of transistors has enabled the creation of advanced microchips, improving the performance of computers, smartphones, and other electronic gadgets. Nanotechnology is also being used in the development of flexible electronics and wearable devices. Energy and environment. Nanotechnology is used in energy production and environmental protection. Nanostructured solar cells have higher efficiency rates than traditional solar cells, making them more portable and accessible. Nanotechnology is also employed in the development of water purification systems, where nanofiltration membranes remove toxins and pollutants from water, and nanocatalysts are used to clean up environmental pollutants. Nanocomposite materials. Nanotechnology enables the creation of lightweight, strong, and durable materials used in industries ranging from aerospace to construction. Nanocomposites can improve the performance of materials by enhancing their strength, resistance to corrosion, and thermal stability. These materials are used in a wide range of products, including automobiles, construction materials, and consumer electronics. 4. Challenges and ethical considerations. Biotechnology. Ethical issues arise in biotechnology, particularly concerning genetic modification, cloning, and stem cell research. There are concerns about the potential use of genetic modification, including issues of biosafety and bioterrorism. In agriculture, the impact of genetically modified crops on biodiversity and traditional farming practices is debated. Green technology. While green technologies offer environmental benefits, there are challenges in scaling up these technologies and ensuring their affordability. The transition from fossil fuels to renewable energy sources requires significant infrastructure investment. Furthermore, some green technologies, such as biofuels, raise concerns about their sustainability and competition with food production. Nanotechnology. The use of nanomaterials and nanometals raises potential risks regarding toxicity and environmental impact. The long-term effects of exposure to nanoparticles on human health and ecosystems remain uncertain, and thus rigorous testing and regulations are necessary to ensure their safe use. 5. Previous year questions. Explain the role of biotechnology in enhancing agricultural productivity. What are the key developments in this field that have contributed to food security? CAS means 2021. Answer. Biotechnology has played a pivotal role in enhancing agricultural productivity through the development of genetically modified GM crops such as BT cotton and golden rice. These crops are resistant to pests and enriched with essential nutrients, improving yields and addressing malnutrition. Additionally, biotechnological innovations like drought-resistant crops contribute to food security in areas prone to climate change impacts. Discuss the advancements in green technologies and their contribution to sustainable development. What are the challenges faced in implementing these technologies? CAS Prelims 2022 answer. Green technologies such as renewable energy, solar, wind energy-efficient appliances, and carbon capture play a key role in sustainable development by reducing carbon footprints and conserving resources. However, challenges include high initial costs, limited infrastructure, and resistance from industries relying on traditional energy sources. What are the applications of nanotechnology in medicine and environmental conservation? CAS means 2021. Answer. In medicine, nanotechnology enables targeted drug delivery, improving the efficacy of treatments and reducing side effects. Nanotechnology also aids in early disease detection using nanosensors. In environmental conservation, nanomaterials are used for water purification and pollutant removal, and nanostructured solar cells offer higher efficiency and renewable energy. This lecture provides a comprehensive overview of the developments in biotechnology, green technology, and nanotechnology, along with their applications and challenges. Let me know if you need further clarification or additional details on any of the topics. You hit the free time limit.